Thank you very much, Johannes, for that introduction. Thank you, everybody, for coming today to Effect Days. I'm super excited to be here with you all this morning. I want to give a quick shout out again, like Johannes did, to all the organizers of this conference. I think that, I don't know if you all know, but the whole reason I joined the company was after Effect Days last year. I had crazy FOMO, and I couldn't keep going in life without becoming a part of the company, and it's been a crazy journey over the last year, but I wouldn't go back. I wouldn't change a thing. So thank you one more time to the conference organizers for always making this event amazing and hopefully continuing to do it every year. So today I'm going to be talking with you all about building effective agents, pun absolutely intended. We're going to be exploring how we can use Effect and its AI integration packages to enable building complex agentic systems, but we're specifically going to focus on taking a practical approach with the AI packages, looking at how we can actually use these software packages to develop the simple composable building blocks we need in order to architect these more complex systems. So, I don't even know if I need to introduce myself anymore because clearly I'm the new mustachioed tech influencer and YouTuber from Effectful. But for those of you who don't know me, my name is Max. I'm one of the founding engineers at Effectful Technologies, which is the company driving the open source development behind Effect and all its ecosystem packages. I'm based out of New Jersey in the States. And you can usually find me hacking on something related to Effect, but I also really love anything related to DevOps or infrastructure or systems administration. So if any of that speaks to you, please come find me during the break, any of the breaks, or at the end of the conference, and I'd love to chat. So I want to talk today specifically about why we and many others are betting on Effect and its AI integrations for building complex agentic systems. I also want to explore a little bit about what makes building these systems so complex in the first place, and maybe talk a little bit about some strategies we can use to combat that complexity. We should also probably talk about what we even mean by the term agentic system. These terms are thrown around a lot and don't ever really get defined, so I'll talk about at least the definition I'll use during this talk. But we're going to spend the vast majority of the talk focusing on how we can use Effect and its AI integration packages to build out these complex systems. A couple of disclaimers. This talk is definitely geared towards folks with at least a basic understanding of Effect and how to use it. We're going to be looking at a lot of code samples during this talk, and there may or may not be, there definitely will be, at least a few dad jokes. All right, so let's get into it. So let's start off by discussing why you should even consider utilizing Effect for building applications that interact with large language models, or LLMs. What does Effect bring to the table? Why should we use it when there are so many other tools available? And I think probably one of the good arguments that we can start with is at the core of any of these systems, they all have the same requirements as building any other production-grade system, right? No, regardless of whether we're using AI or not, we still have the same requirements. And developing any production-grade system is hard. It's a hard thing to do. We as developers have to face a mountain of complexity that we have to overcome in order to get these systems deployed into production, especially when using TypeScript. We need to make sure these systems are fault tolerant, that we can reason about how they're going to behave when faced with the errors that we're expecting, but also that the system continues to function as expected in the face of unexpected errors. We need to make sure these systems are testable, that we have the ability to reason about how the system is going to behave, and also have confidence that our code is going to work as expected once deployed. We need to make sure these systems are scalable, and I don't just mean scalable in terms of utilization, right? That's usually what we think about when we think about scalability, but I also think the systems should be scalable in terms of the code base. We should keep them maintainable, we should keep them easy to work with for developers, and onboarding new developers shouldn't be an arduous task. And finally, these applications should be introspectable. We should have really good insight into the running application so that we can be alerted if something's going wrong, right? We want to know if something's going wrong in our production systems. And I think this goes with pretty much any system, as I said before, but the complexity is compounded in applications that are powered by large language model interactions. And this is for one main reason. Systems that are powered by LLM interactions are inherently non-deterministic. So what does that mean? For the same inputs that you put into the system, you may get totally different outputs the next time you interact with that system. It can introduce substantial randomness and variability as you're working with the system. So for example, if you call a system that interacts with an LLM with the same prompt twice, you may get totally different output, totally different tool calls used. And so this is really in kind of stark contrast to our traditional software systems, where usually you get the same output for the same input. And this complexity gets further compounded if the LLM is also dynamic in that it can control sort of which code paths it takes through the application. And that gets a little more into like the agentic side of things, where the LLM really has a little more control over what it's doing. But again, the complexity just keeps growing as we add more features to these applications. So how do we handle all of the added complexity that comes along with building systems that also leverage features of AI? Well, I think the answer is that we need to lean into our tooling. And I'm not trying to be egotistical or anything, but I'm going to quote myself from earlier this year or last year in the fall. In systems where non-determinism is the default, I think that effect is the antidote. We want to lean into tooling which is expressive enough in order to model all of this complex behavior. We want to maintain reliability and scalability, as we discussed before. We want to be able to test our applications without bending over backwards for whatever framework we're using. And we want to have clear insight into the running application as well. So all of the above and more come out of the box with Effect. And so that's why I think Effect really shines in the face of all of this complexity. Effect provides many tools to deal with the chaos that comes along with building AI-powered applications. It's composable by default, so we can build up really complex systems from very simple composable building blocks. We can define and track errors as part of our domain, which allows us to have very clear semantics excuse me, over how we're going to handle these errors. We can abstract business logic into easily injectable services, which means our code becomes very compartmentalized and easily testable. And we have out-of-the-box instrumentation that we can litter throughout our code base that gives us extremely clear insight into our running system. So hopefully I've convinced you that Effect is the correct tool for handling all of this complexity. But I've been kind of using the term agentic system and AI and a lot of different buzzwords, all interchangeably at this point. So let's talk a tiny bit more about what I mean by agentic system. So Anthropic published a blog post back in December where they talked about patterns for building agentic systems. And they also gave a definition that I kind of like because it's extremely simple. An agentic system is generally a system that utilizes what they call an augmented LLM for interactions to accomplish different tasks. So you interact with an augmented LLM, which we'll talk about in a second, to accomplish various tasks. And then they classified agentic systems into two major categories. Workflows, where code paths and execution is kind of predetermined. There's minimal dynamicism, so the developer is really in control over what's going on. And then more agents or agentic systems plus, whatever you want to call it, where execution is much more self-directed by the LLM based on it making decisions about what the best thing to do next is. And so these two, I think the two categories are helpful to keep in mind as we go through this. We're primarily going to focus on workflows during this talk, but it's helpful to keep this in mind. And I mentioned before, at the core of any agentic system is what Anthropic refers to as the augmented LLM, where you've still got your normal input-output interactions with the large language model, but you've also enhanced that LLM with different features to kind of augment the response that you get, right? We give the LLM the ability to retrieve information so it can generate search queries over different data sets. For example, a company's internal knowledge base, you could give the LLM access to that to query for information in order to handle a input from a user. You can give an LLM access to various tools that it can use to answer a query, like giving it the ability to use a web browser to search for things. And you can also give an LLM memory, which can either refer to expanding context windows available to the LLM, or you can also let the LLM store information into external knowledge bases. And Anthropic makes the assertion that once you've got this basic building block, you can basically use it to compose together much more complex agentic workflows. From here on out in the presentation, we're going to take a practical look at how we can use Effect-AI integration packages to achieve the augmented LLM. Unfortunately, we don't have the time to actually get into implementing all of the agentic design patterns that Anthropic published in their blog post, but I did start working on porting all of Anthropic's examples from Python into Effect, and the repository that I've just open sourced for this talk contains 3 out of the 5 patterns already implemented with the Effect-AI packages that you guys can look at. And by the end of the week, we'll have the rest all done as well. So let's keep going. We'll start off by talking about how we can use Effect first just to interact with LLM providers. Given that a core piece of the augmented LLM is first just being able to talk to the large language model, right? And this past fall at the Effect meetup in San Francisco, I introduced Effect's AI integration packages, which first consist of the base Effect-AI package, which is meant to provide a single unified interface that you can use to describe interactions with LLM provider services. We'll talk a little bit more about that in specifics in a bit. And then we also have, so far, 2 provider integration packages that allow us to provide concrete implementations of the different generic services from the base package that allow you to talk directly to either one or more providers in your application. So now we'll focus a little bit on how we can actually use these packages to do what we want. In order to talk about how we can interact with LLMs, we first need to describe how we can describe interacting with an LLM using our AI integration packages. Our goal with these packages was to allow developers to focus on the business logic of their application without having, and then plug in the provider you want to use later, without having to worry about all of the different provider-specific quirks that kind of come along with each provider. So you get kind of like a generic interface that you can use, and you let us worry about the complexity of unifying all of the different providers together. So in this example, we're using the completions service from the base Effect-AI package, which is meant to represent generating text from an LLM. And you can see here we're accessing the completion service in our program here, and then we're using the completion service to generate some text. In this case, we want to generate a hilarious dad joke because everybody knows that I love dad jokes. And then we're just logging the response that we get back from the LLM to the console. And if we take a look at the type of this program, you'll see that now we end up with completions in the requirements of our program, which means that at some point we need to provide a concrete implementation of completions to actually get this program to run. And that's what the provider integration packages are for. So if we use the OpenAI provider integration package to provide the concrete implementation of completions, we would end up interacting with OpenAI's chat completions API. But if we instead plug in Anthropic, we'd end up using their messages API. But the responses that you get back are unified into a unified data model that we call AI response, so that, again, you don't have to worry about all the different quirks that come along with these different providers. So now that we've got a program where we're actually using an LLM to do something, right? We're trying to generate some text here. we can actually use one of Effect's provider integration packages to try to make the program runnable. So provider-specific integration packages, like I said, expose concrete implementations of services they support from the base package. So we're using completions in our get-dad-joke program, right? So in order to make that program runnable, we decided we want to use OpenAI. So we can use the OpenAI completions module from the OpenAI integration package in order to try to get this program to run. So once we've imported OpenAI completions, we can then use OpenAI completions to create a data type that we call in our AI integrations the AI model. And an AI model is meant to describe a type that will provide a particular service, in this case completions, and then will require a particular client or maybe other services in order to actually be able to run. And bear with me for a second, because I know this looks a little bit different than maybe some of the code you've seen written in Effect before, but we're going to get into why we took this approach and why I think it's definitely the right approach and also provides you as the developer with a ton of flexibility. So like I said, this AI model using OpenAI completions.model gives us a AI model that will create us a completion service that we can provide to programs. It's going to use GPT-4o as its model. And then we actually, when we want to use this, first need to build it in our program. So in order to do that, you can just yield it or pipe it to another effect method, whatever. They're just effects themselves, so they're yieldable. And then we actually get the concrete built model itself, which we can then provide to programs that we want to use it. So once we provide the GPT-4o model to our get-dad-joke program, the completions requirement is satisfied for that program. And now if we take a look at the type of our main program, the OpenAI client is the only thing left that we need to provide. So again, this might look a little bit different than some of the effect code you've seen written before. But what are the benefits of taking this approach? Well, one of the major benefits is if we want to run many different programs with the same model, we can do that. Once the model's built, we can provide it to as many programs as we want. That's kind of cool. But we can also mix and match providers. So if we also want to use, like let's say that we know that Claude does a fantastic job with generating dad jokes. It does not. Anybody at my workshop yesterday knows that it does not. But if we think that Claude does a really great job and we want to use Claude to generate our last dad joke because we want it to really pack a good punch, we can also import Anthropic completions, use the Anthropic completions to interact with Claude 3.7 Sonnet, and then build that model in our program and provide it to the last get dad joke program. So you can see how mixing and matching models is also really easy with this particular approach. And I'll draw your attention again. So this is a highlight of mixing and matching the different models, but I'll draw your attention again to the type of main, which now also tells us we need to provide an Anthropic client to our program. So all of the get dad joke program's completions requirements have been satisfied, but now our main program is telling us, okay, you just now have to give us the clients to interact with Anthropic and OpenAI. And I think kind of one of the main benefits of this approach is that it really cleanly supports the service constructor pattern in Effect. So for anybody who's leaning very heavily into layers in their applications, which I think is a really good model to take for composing services together, this approach really shines when you want to take all your LLM interactions and package them up into different services. So in this case, we've got our dad jokes service here. Great name for a service. And inside the constructor for that service, we first build our two models. So now we've built these two models and we can use them in the actual interface that we expose as part of this service. So for get dad joke, and if we want to get a really groan-inducing dad joke, we can provide Claude to that one. And what's cool about this is the AI requirements are now hidden from the interface of the service that's exposed. When we actually use this service in a program, we're only left with the dad jokes service as our requirement. And instead, so we can use dad jokes as we would normally, and we don't have to worry about the fact that it's interacting with LLMs. And instead, the fact that there's a requirement on Anthropic and OpenAI and whatever is lifted into kind of layer composition. So now you can deal with the fact that you need to provide an Anthropic client and an OpenAI client and everything like that on the level of the layer. And for anybody who's not familiar with Effect.service yet, it is in the docs. It's kind of like our new way of creating services where you get a tag and a layer at the same time instead of having to define them separately. And the default property here is the layer that's generated for you. So we end up with a layer that produces a dad joke service, but ends up requiring the actual clients we need. So up until this point, we still have the need to create clients that we can provide to our program so that we can finally make it runnable. And each of our integration packages export modules that make it really easy excuse me, to create clients as well. In this case, we're using the OpenAI client module to create a layer that will produce us an OpenAI client, and it ends up requiring an HTTP client implementation, which we'll talk about in a second. And the layer constructor that is exposed from these modules is really helpful when you're prototyping because you can just hard code your API key right there. But obviously, when you get into production, you want to do things a little bit more properly. So we also export a layer config constructor where you can provide configs in line to give the layer everything it needs, and you're still ending up with a layer that produces the client that you want. And when you're ready to then make the program runnable, we also have to provide some implementation of an HTTP client to these LLM provider clients because all of them use HTTP, right, at the moment, I think. So in this case, we know we're going to be running with Node. So in order to avoid becoming dependent on some platform, we keep HTTP client in your requirements. You give it the one that you want. And once we provide this to our main program, all of our requirements are satisfied if we're not using Anthropic as well. And we can now run this program. But this is all well and good. This is cool. It's fine. But we haven't really talked about, handling failures. Obviously, when interacting with applications that depend on calling out to an LLM, there are many different failure scenarios that need to be handled. Network outages, provider outages. Providers do go down. Incorrect request response formats. And in particular, as a dad, it's extremely important to me that when I think of a really great dad joke, that it's delivered to my victims, children, without any issues. I want, even if it fails, I need to retry that as many times as possible. So we've actually introduced something that I want to talk about in this to kind of motivate error handling, something called the AI plan. So let's motivate that for a few moments. If we've rewritten the logic of our dad joke to now potentially fail, right, with either a network error or a provider outage error, our main program will now reflect that, right? We could potentially have a get dad joke error coming from our program here, even if we've satisfied the model. So how can we potentially deal with this? Well, AI Plan is a new module that we've just released, I think a week or two ago. And what it allows you to do is build up a plan of execution by composing different models together. So we'll go through this example and then maybe it'll become a little more clear. But in this case, the first thing that we do is we create a base AI plan from our GPT-4o OpenAI completions model. And from model takes some arguments here. So what we're saying here is, as this first step in this plan, we want to try interacting with OpenAI 3 times with an exponential backoff, and we only want to do that while the error is a network error, right? So if we have a provider outage, we want to fall back to the next provider immediately. So how can we actually do the fallback? Well, AI plans are composable. So you can then add a second step to your plan where you say, okay, if everything with OpenAI fails, if all the conditions we have in our retry logic and everything fail, fall back to Anthropic and use Claude to generate our dad joke. And only do that if there's a provider outage. And what you end up with is now this new AI plan data type, which is kind of similar to AI model. We generate a completions service for you, and you end up requiring some clients. But you also have the error in the type here that's going to be handled by the plan. And we're still working on adding more methods to the AI plan module. So at the moment, the error still shows up in our main program because it's possible that we go through all of the retry logic and everything, and we still have that error as part of our program. But you can yield the plan just like you would yield a model, and then provide the plan to the get dad joke. So what's going to happen here? It's going to try OpenAI. If all of the conditions we've set fail, it'll fall back to Anthropic. And then if everything else fails, the program will fail as a whole. So what's really powerful about this is that it allows you to very granularly describe and plan out how you're going to execute with different providers as part of your AI interactions. If you have suggestions, by the way, about different things we could add to AI Plan, please let us know. We've kept the API surface intentionally small for now because we're looking for feedback. Now, there may be some of you out there saying, yeah, that's all pretty cool, but I still can't write my code in a provider-agnostic way. I need to set this very specific configuration parameter in this very specific location for my code to work perfectly, and I know this is exactly what I need because it's fantastic. And we support that too. So if we have our get dad joke program here again, let's say that we want to set some specific OpenAI configuration. Well, all of our modules that support overriding particular pieces of configuration export a config override method that allows you to override those configuration variables. And what's cool about this is you can mix and match them together in your program, and those configuration variables will only be used if that client is in use. So if you're not using Anthropic to run this program, great, we won't use those configs. But if you are, then those configs will be applied. And what's even cooler is the AI models themselves take default configurations. So if you want to set defaults for this particular model, you can do that. You can override them in particular programs if you want to. So the configuration that you apply as part of these LLM interactions is extremely flexible. So we've seen a bunch of features Effect-ive integrations have, but we still haven't really explored any of the 3 pieces that make an LLM interaction augmented. Though some providers like OpenAI are offering vector stores and file search and other cool things to simplify building up the augmented LLM, my personal opinion is that the features and services to support this, to support retrieval in memory specifically, are best implemented in userland to avoid vendor lock-in and other things. And one feature of the augmented LLM, though, that we can help with, that we want to help with, is dealing with tool calls. Effect-ive has I think, a pretty cool way of defining tool calls at the moment. We have a module called the AI Toolkit, which allows you to package up all the different tools that you use into a toolkit that you can then build as part of your program and provide along with interacting with an LLM. So, for those unfamiliar with how tool calls work, it's basically when you submit a query to an LLM, you can also submit a list of tools it can use, and it will respond to you saying, like, I want to use X tool, so you use that tool and then send it back to the LLM. But before we can let the LLM use the tools, we have to define the tools. So first, let's talk about how we do that with the AI Toolkit. So here we're using schema.taggedRequest, which most of you are probably familiar with from a lot of other APIs that we have. We lean very heavily into schema for doing things that need to be serializable. And in this case, we're saying our tool call is going to have a search term that we can provide. It's going to succeed with a string and never fail. And this tool call is going to allow us to get some random dad joke from the IconHasDadJoke API. Once we have our request defined, right, we're saying this is the payload we're going to submit is a search term. We're going to get back a string. We're never going to fail. Once we have that request defined, we can add it to an empty AI toolkit. And now we have our dad joke tools. We can keep adding tools if we want to. And then, for those of you familiar with the HTTP APIs that we have, you can then implement the handlers for each of your tools. So dad joke tools, a toolkit comes with an implement method, which allows you to provide an actual implementation of each one of the different tools you have in the toolkit. And the implement method itself then returns a layer that has all of the different tools already packaged up in it, which you can then provide to your program, and your program now has all of the things that it needs to be able to use these tools. So this is great, but how do we actually use the tools? Well, once you've got your layer built and your toolkit defined, you can just yield the toolkit in a generator the same way that you yield the models, the same way that you yield plans. You have to build the toolkit, and then you can just pass it along with any request to an LLM using the completions.toolkit. And then we also have streaming versions of these APIs as well. But we try to make it as easy as we can to use tools as part of your LLM interactions. So again, this API is early. Everything in the AI packages is considered alpha at this point. So if you all have suggestions or things that you think that we can do better or missing features, please let us know. We really, really, really are looking for feedback, and we need it. So some future directions, and we'll close out. We are still working on implementing different provider services. At the moment, we just support completions or text generation and embeddings. But we're working on implementing others. I have thoughts about the real-time API from OpenAI. I have thoughts about batching and things like that, which other providers offer. So we're working on those things. Tomorrow, you can find us hacking on potentially an MCP implementation that's native to the Effect-ive packages. And then we have some other unimplemented features that I have that I want to work on. Just like different features that I think our AI integrations can probably support. So for those of you who want access to the code, feel free to scan the QR code. That'll give you access to the repo. I'm working on building the other patterns that I mentioned before, but I really want to thank you all for your attention this morning, and I also want to thank you all for coming to Effect Days. So yeah, very much appreciated. Thank you.